So here's an example that is similar to 12.5, number 10. Find the distance from a line to a point. And we're going to be using vectors. So I'm going to do a simple example. So let's say that this x-axis is the line, and then the point is right here. So what's the distance between that point and that line? Well, it's a distance of 4. So if you just drop a perpendicular down, it's a distance of 4. But now do it using vectors. Okay, so first of all, I need the equation of this line in parametric form. So I could say like, let's say that right here is 5. That means that the vector for that line would be 5, 0. In order to make the equations of a line, I also need a point. So let's say that point over here is 10, 0. And then I'm going to call this point P, and this is point Q. All right, so the equation for the line would be x equals 5t plus 10, and y is always going to equal 0. Now for the rest of this problem, I don't really need this part. So on the homework question, you'd be given this part, and you need to find the vector, which would be the numbers that are in front of t, and also the point, which would be these extra numbers over here. Okay, now what I'm going to do is I'm going to find the vector from P to Q. So just subtract those. So from P to Q, that would be 10 minus 5. And then it's going to be, oops, I went the other way. I should have gone Q minus P, so that's actually a negative 5. And then 4 minus 0. So let's see, that would mean go over by 5 and then up by 4. And so if you're going from the origin, that's actually this vector. But then, as long as you keep the distance the same and the angle the same, you could pick it up and put it over there. Okay, so I've got that vector. So I've got this vector, which is this one right here. And I've got this vector, which is just a copy of this one. Then what I'm going to do is, for these two, I'm going to take the cross product. Now, you can only take the cross product of vectors if they're in 3 dimensions. So what I'll really have to do is say this piece of paper, z is equal to 0. So this vector is really negative 5, 4, 0. And then I'm going to do cross product with this vector, which would be 5, 0, 0. So let's see, what does that equal? So I need the I, J, and K. Negative 5, 4, 0, and 5, 0, 0. Okay, so for the cross product, when I cross out the I, that's going to be 0 minus 0. Don't even need a calculator for that one. For J, that's going to be 0 and 0. And then finally, we get this one, which would be 0 minus 20. Okay, so then the distance will equal, you take the magnitude of the cross product. So this vector right here, or this vector right here, I'm going to call that the vector v that comes from the line. So we took the cross product of these two, so take vector v cross product with pq, and then we're going to divide by the length of vector v. And that will give us this distance, which should be a 4. Let's see if it worked. So the length of this vector, well, you just square plus square plus square, and then take the square root of that. So that's actually just going to be 20. And now find the length of this vector, or this one. And that means square plus square plus square, so that would be 25, and then take the square root. And so the answer is 20 divided by 5, which is 4. So sure enough, the length from here to here is 4. But I did it using vectors. That was pretty cool. Hey, while I've got you here, I just wanted to show you something else. And that is area of a triangle. Of course, we know that that equals 1/2 the base times the height. If you went to 5th grade, you should have learned that. But how do you do it using vectors? Well, let's say that you've got two vectors. So this vector right here, I'm going to call that vector x. And then this vector, I'm going to call that vector r. So if you have two vectors, then you could go like this. I'm going to make a right triangle. And then this is theta right here. Okay, so for one thing, I know that sine of theta is equal to, you take the cross product of these two vectors, x and r, and I should be writing the little arrows on them each time. Sometimes I go fast and I don't write the arrows. And then divided by the length of x and the length of r. Or I could take this and multiply it onto the other side. So the length of x times the length of r times sine of theta is equal to the cross product. And this formula right here comes from the law of sines. Okay, so anyway, I know that area is equal to 1/2 the base times the height. Well, the height, I don't have anything on there, so I'm going to call that vector y. So I know that area equals 1/2 the length of x times the length of y. Good old 5th grade 1/2 base times height. Okay, now to math 24, trigonometry. What does sine equal? So sine is opposite over hypotenuse. So over here I've got sine of theta is equal to opposite, which would be the length of y, divided by the length of r. Or right here, I could solve for the length of y, and it's going to be the length of r multiplied with sine of theta. So that means that right here, I can replace y with this thing. So area of a triangle equals 1/2 the length of x, and now replace y with this part. So that's the length of r times sine of theta. Then notice this thing right here says if you have the length of x, the length of r, and sine, you can replace that with the cross product. So the length of x, the length of r, and the sine, all of that can be replaced with the cross product. So that means area of a triangle is equal to 1/2 the length of the cross product of those two vectors. That, to me, is amazing. You could take something from 5th grade and you could use 3rd semester calculus to do the same thing. Cool.